Okay, we finished heaps yesterday, so let's do some backtracking. How many problems have I done? 167. Okay. Combine and K, return all possible combination. Okay, so backtracking. I think I done like a bunch. I sort of like done like variations of these problems, but I always forget that like it's always good practice to do it because the recursion sometimes gets a little trippy. So like base case, if the size, if our, if the size equals k, I guess k groups, right? Yep. And we want to do 1 through n, I assume inclusive because 4. Yep. And add to result, and then basically for every possible value, add to list, and pop out. So I think that's basically the boilerplate. 1 2 1 3 1 4 2 3 2 4. So let me see. It's more like a tree. If I like visualize this like a tree, right? So first we start with an empty. So like these are all of. Let me Okay. Let me. Okay. Okay. Never mind. Let's just do this shit, right? I think it's 1 through 4. So. Right. 1 2. So 1 through 4. So we can choose. Obviously, in our empty list, that's what we start with. We can take a 1. Or we could take just a 2. Or just a 3. Or just a 4. Right? And then within each like node here, we basically say, okay, I can't take a 1 anymore, so I can only take either 1 2, right? Or I can take a 1 3, or I can take a 1 4, and that's all the values. Again, every time we detect it, that's it. So that basically, probably should put a little comma here. Here I could do I could take a 1, but I can't because that would be a duplicate. So I could do a 2 3. I could do a 2 4. I could do a 3 4. I can't do a 2 3 2 because that's already taken, and then there's nothing else for 4. So we actually would prune this one. This one didn't exist. So how do I prevent duplicate? That's a little tricky one. I think that's the way we do that is forward momentums, I guess. Like, okay, from here I can only choose value here and beyond. Same thing here. I can never go backwards, so I could only do +1 from there. I think that's the idea. So let's write the bullet point real quick. Okay, so we'll do, I guess, def backtrack. All right, this is really annoying. I need to figure out a way to disable that, but anyways, if length of, okay, so I think we need to basically here add I guess groups. If length of groups equals k, res.append groups. Let's make a copy of it and return out of here. That's our base case. Obviously, we're gonna call return res, and then we'll do res equals. We'll do it here actually. Res equals this, and then we'll call backtrack groups. We'll do or empty list. And it will kind of side effect into here. Okay, so okay. Anyway, so backtrack. We need to make a function that goes through these stuff. Okay. You know, I can maybe make a value and pass that in, so I know what index to go from. But the problem with that is I would have to like figure out a way to like fix indexes and stuff. Like I think the idea is to have like forward momentum so we prevent duplicates. So like I can only once I add a value in, I can only add values from this point and beyond. So let me do this. So I basically will do this. So maybe I can have maybe I could add like 4. So maybe I can build a list like all the values like this. Maybe I can have like 1, 2, 3, 4, right? So I know what values to add. 1, 2, 3, 4. Oops. Okay, what am I drawing, bro? 3, 4. So I have these stuff here. I have all the values 1, 2, 3, 4, and then one, two, three, four. 1, 2, 3, 4. Okay, okay, how could I okay, so I have the value n. If I generate a list of values, I can kind of prevent it from picking itself. And I can pick all these values essentially. Right? And so I can do that. Like each will be its own starting point, and each will become a starting point and beyond. So I think maybe having a list is helpful. Let's do that. Ooh, values here. We'll do value for every value in range of n plus 1. Print values. Let me just get rid of that. Okay, we need to do 1. Okay, perfect. That's what I needed. So we'll call backtrack here. I think we should have an index as well. And we'll do for every v in values of from. So basically what I need to do is from index and beyond. So like if it's obviously, okay, we first start, we start from, okay, we will pass in obviously an empty list, and we'll also start from 0. So the first iteration, we're going to start from 0, 1, 2, 3, right? And this will, the first tree call, it's going to go through our first, like, I guess, breaths here. I see an issue. I actually only go... I should actually not... I should prevent it from going any further. Let me do... Let's do this. Let's do this. Instead of index... No, screw this index thing. I don't need an index. I just need the values. Right? I just need to do what, like, here. Like, I still would go through all the values possible and then only add numbers, like, from, like, a actual starting point. Like, we'll call this the starting point. From +1. So, like, we'll only go beyond this part. That's why I like the index thing. I do actually need the index. Let's put an index. Yeah. So we'll do this. So for every values in values of starting from index and beyond. So like 1 and beyond. So like we'll go through all of them for that layer, and then for each individual one we'll go here first. Like, all right, from here I'm want to add +1. So we'll do so from here we're gonna do groups.append value, and then we'll recurse backwards, backtrack. So backtrack groups, and then we'll index +1. So index +1, I don't want to go too many times, so so we need to prevent that. So let's see, how many times could I actually go? And then also probably want to groups.pop that value so we can go to the we could use another value like 2, right? And then yeah. Wait, this is gonna cause me trouble. I know it is. Let me just prevent it. How do I prevent this from? If index equals length of values, probably want to return out, so we can prevent that from happening. So let's try this. Oops. So we need to put add groups, and we'll start from index 0. Of course, I know how to misspell items. Okay, so we got 1 2 1 3 2 2 2 3. Okay, it's way too many. I think I got too many duplicates. How am I getting? Wait, how is that happening actually? Let me see. Print values. Let me see what it kind of generates here. Like 1 2 3. All the ones. Basically, I need to generate a 1 2 3 4, and then I need to generate a 1 2. A 1 3. Basically 2 3 2 3 4 3 4 then 4. 2 3 4. Okay, that's the problem. Okay, I probably should Do I need to redo this as well? I don't know if that makes sense. Wait, I definitely need to... Right? Does that make sense? I should basically generate 2, 3, 4, 2, 3, and then 4. Having this 2, 3, 4, 2, 2, 4, that's actually very bad. So, I don't know. Hold on. Is this causing the issue? Nope. Let me, instead of doing this, let me just generate the values. I don't like this, like, okay, we'll do for every and in range of, we'll do like start, which is basically the starting one. Yeah, we'll call it start. So we'll do start to n plus 1. I think that's a better idea, because like from here I'll start from 1, because like, yeah, that makes sense, because that's the first value. So we start from 1, yeah, and then we generate that, and then from this level we start from 2. From this level we start from 3, we start from 4. So the groups dot append num, and then we do backtrack. We don't need this anymore. Backtrack groups, then start. Basically just the next, the number right now plus 1. So for example, okay, since we started here now, when I go, what I want to generate is 2, 3, 4. So we need to do from 2 to 3. So like plus 1 here, which is 2. So 2 to 4. And then we'll do groups dot pop. That should work. I don't even need this anymore. Okay, there you go. Right? Oh, it's just slow. Okay, perfect. See you guys tomorrow.